42.2, that is my variation. So from algebra, how do I undo a squaring? I take the square root, right? So if I take the square root of 42.2, I get 6.496. Alright, let's just say that, yeah. 6.496. And this is my standard deviation. Okay, we have a question.
Do you always divide by 4, or does it depend on how many?
It depends on how many we have, okay? And I'll I had 5 numbers and I took 1 away from 5, and that's how I got 4. I'll summarize all of this in a moment here, okay?
Wait,
Yes.
how come if it's 42.2, why do we have 42.6?
Oh, I'm sorry. 42.2.
Thank you.
All right. Is that okay?
Yeah.
Yeah.
Yes, we have a question.
Why when you're using the squares, the negative numbers, you just use?
Oh, okay. Yeah. What happens when you multiply a negative number by itself? It becomes positive. Okay. So negative 7.8 squared is the same thing as 7.8 squared. Okay. So just be careful. You know, when you type in your calculator and you put in negative 7.8 and you square it, it might give you back a negative number. Why would it do that? Yeah, because if you remember order of operations, it says we do exponentiation before we do multiplication, right? So we're going to do the squaring before we do the multiplication. And the way the calculator sees it is it sees a negative sign as a -1 times a number. Okay? So if it sees the number -8 squared, it sees this as, okay, do the 8 squared first and then put a negative there. Okay? What you probably need to do is you have to write -8 squared. Okay? And then it will treat this as this. Okay? Because this in the calculator is going to give you -64. That's wrong. But this will give you 64. And that's what we're doing. Okay? So just be careful when you're dealing with your calculator. Okay, so let me just summarize what we did for the Johnson's ages, okay? So the standard deviation of the Johnson family, the standard deviation is 6.496. Okay? And this is what we did, okay? First, we found the mean age, right? We find the mean. And so for the Johnson family, the mean age was 9.8. Okay. What was the next step we did? We found how different was each child from the mean. Okay? That's basically, another word for that is the deviation. What's the distance between each child's age and the mean? And so to do that, how did I get the distance from each child's age to the mean?
You subtracted.
I subtracted the mean from each age, right? So we find the distance from the mean. For each number. Okay? And we did that by subtract the mean from every number. Okay? That's how I got these numbers, -7.8 and 4.2 and 8.2, right?
So whatever you get, you have to subtract from
I
the
subtract that number from each number in my data set. I'm getting the distance from that number to that, okay? then I said, well, rather than just adding those up, what do? We squared each number, okay? So square the distances. Okay. At the end of this, everything's gonna be positive, okay? So everything will be positive after you square it. And then I added up all of those squares. Okay, because it's almost as if we were finding the average, right? To find the average, you add them up and you divide by how many you have. But in this case, I add them all up, but then I divide by n minus 1. Okay? So 1 less than what you would normally use for the average. For every time you're doing the standard deviation, you're doing n minus 1. Okay. If you're curious as to why it's n minus 1, it's this thing called Bessel's correction. It's part of this, not complicated, but it's part of this idea of an unbiased estimator. I don't think you guys are going to worry too much about it. Okay. So just go with me and say we're going to use n minus 1. If you're going to study statistics as a career, you're going to have to learn why it's n minus 1. But I think for you guys, it's okay. All right? We divide by n minus 1. Okay? The number that we get at the end of this, what is this called?
The deviation?
Now this one's called the variation. If we stop here, this is called the variation. Okay? So if I stop here, this is the variation. Okay? But if I do the next step, which is take the square root, then that gives me the standard deviation. Okay. How do we feel about that? Okay, so before we take a break, I want you guys to calculate the standard deviation of the ages for the Miller family, okay? And then, and after the break, we'll go over the answer for the standard deviation of the Miller family. So these are the steps for finding the standard deviation.